Good morning. Today we will discuss regarding introduction to pneumatics. So first of all, we will see what is fluid power. So fluid power is the energy transmitted and controlled by means of a pressurized fluid, either liquid or gas. The term fluid power applies to both hydraulics and pneumatics. So hydraulics use liquids, oil or water under pressure, while pneumatics use compressed air or other neutral gases. So this pneumatics, it is based upon the Pascal's law. The pressure in a confined fluid is transmitted equally to the whole surface of its container. So accordingly, the pressure at any point in a body of fluid is the same in any direction. So P equal to F upon A, where P is equal to pressure in pascals, F is the force in Newton, and A is the cross-sectional area in meter square. Now pneumatics, the second branch of fluid power, which utilizes the freely available air as the working medium, that is to transmit power from its source to destination. The major difference is that air is compressed and under pressure at the time it is delivered, even if there is no load on the system. Whereas in hydraulics, pressure is developed only due to presence of load, that is resistance to flow. Now, these are the components of the pneumatic system or various elements of the pneumatic system. So you can see, so first element is the compressed air generating section, then second is air storage section, then air cleaning section, air conditioning section, then controlling section, and operating section. So these are the different sections involved in pneumatic system. So according to that sections, the pneumatic system uses different components. So basic components of pneumatic system. So you can see in a diagram. So first component, that is intake filter, then compressor, then cooler, separator, receiver, then secondary air treatment, then the control valves and the actuator. So actuator means it is actually a application. For that, the pneumatic system, it is designed. So we will see one by one. So air filters. So these are used to filter out the contaminants from the air. Second component is compressor. Compressed air is generated by using air compressors. Air compressors are either diesel or electrically operated. Based on the requirement of compressed air, suitable capacity compressors may be used. Third element is air cooler. So during compression operation, air temperature increases. Therefore, coolers are used to reduce the temperature of the compressed air. Next element is dryer. The water vapor or moisture in the air is separated from the air by using the dryer. Then control valves. So control valves are used to regulate, control and monitor for control of direction, flow and pressure, etc. Air actuators. So air cylinders and motors are used to obtain the required movements of mechanical elements of pneumatic system. Then electric motor, it transforms electrical energy into mechanical energy. It is used to drive the compressor. And receiver tank. The compressed air coming out of compressor is stored in the air receiver. So these are the different components of the pneumatic system. Now air generation and distribution. The generation of compressed air starts with the compression. The compressed air flows through an entire series of components before reaching the consuming device. The equipment to be considered in a generation and preparation of air includes, these are the various equipments: inlet filter, then air compressor, then air reservoir, air dryer, then air filter with water separator, then pressure regulator, air lubricator as required, and drainage points. So these are the different equipments required in pneumatic system. And these are the equipments to be considered in the generation and preparation of air. These equipments are required for generation of air. Then we will see one by one the components of pneumatic system. So first it is intake filter. So it is used to clean and filter the air used for systems. So before the surrounding air enters the compressor, it must pass through the filter to remove most of the dirt and other solid contaminants. So this is the first stage before the air before receiving to the compressor. These filters can be of dry or wet type depending on the compressor manufacturer and the application. Then air compressors, that is the second element of the pneumatic system. A compressor is the most common industrial energy supply unit that converts mechanical energy into fluid energy. So it is a design to take an air at atmospheric pressure and deliver the received air to a closed system with a certain volumetric flow rate at higher pressure. So it takes the air at atmospheric pressure and delivers to the system at higher pressure. That is the function of compressors. So compressor, it is a mechanical device which converts mechanical energy into fluid energy. The compressor increases the air pressure by reducing its volume, which also increases the temperature of the compressed air. The compressor is selected based on the pressure it needs to operate and delivery volume. So the classification of the compressor is positive displacement compressors and dynamic displacement compressors. So the positive displacement compressors include piston type, vane type, diaphragm type, and screw type. So this is a one of the diagram of multi-stage compressor. So you can see that is the first stage, that is at low pressure, and at the left hand side you can see the at the right hand side you can see the second stage, that is high pressure, and in between first stage and second stage there is a intercooler, and there is a inlet valves and the connecting rods. So there is a inlet port and the outlet port where you will get the high pressure from low pressure. So you can see the working. As the pressure of air increases, its temperature rises. So it is essential to reduce the air temperature to avoid damage of compressor and other mechanical elements. The multistage compressor with intercooler in between the two stages, that is shown in the figure, it is used to reduce the temperature of compressed air during the compression stages. The intercooling reduces the volume of air which used to increase due to heat. The compressed air from the first stage enters the intercooler where it is cooled. This air is given as input to the second stage where it is compressed again. So the multi-stage compressor can develop a pressure of around 50 bar. Then next element is the receiver tank. It is the next element to the compressor. The air is compressed slowly in a compressor. But since the pneumatic system needs continuous supply of air, this compressed air has to be stored. The compressed air is stored in an air receiver, that is shown in a next slide. There is a diagram in a next slide. The air receiver smoothens the pulsating flow from the compressor. So we will see the air receiver. So you can see the inlet from the compressor. Then there is a storage tank. Then on a tank there is a safety relief valve. Then the pressure gauge, thermometer, then shut-off valve, and manhole, and a water drain. These are the various elements of air receiver. So air receiver smoothens the pulsating flow from the compressor. It also helps the air to cool and condense the moisture present. The air receiver should be large enough to hold all the air delivered by the compressor. The pressure in the receiver is held higher than the system operating pressure to compensate the pressure loss in the pipes. Also, the large surface area of receiver helps in dissipating the heat from the compressed air. So generally the size of receiver depends upon delivery volume of compressor, air consumption, pipeline network, type and nature of on-off regulation, and permissible pressure difference in the pipelines. So this is regarding the receiver tank. So this is a diagram of air receiver. So we will see the air treatment stages. So this is a diagram of stages of air treatment. You can see air in, then there is a inlet filter, then there is a compressor that after filtering the air, it is entered in the compressor and it is compresses. Then it is passed to the primary air treatment. It is passed to the cooler, then main line filter and dryer, and then it reaches to the receiver tank. And then after that, the secondary air treatment is there, that is by air service unit, and then it is applied to the load to carry out the work. So for satisfactory operation of pneumatic system, of the compressed air needs to be clean and dried. So atmospheric air is contaminated with dust, smoke, and is humid. These particles can cause wear of the system components, and presence of moisture may cause corrosion. Hence, it is essential to treat the air to get rid of these impurities. The air treatment can be divided into three stages as shown in the figure. So, these are the stages of air treatment. So, in the first stage, the large size particles are prevented from entering the compressor by using intake filter. This is the first stage. The air leaving the compressor may be humid and may be at high temperature. The air from the compressor is treated in the second stage. In this stage, temperature of the compressed air is lowered using a cooler and the air is dried using a dryer. So you can see the second stage, cooler and dryer. Cooling and drying of the air, it is carried out after compressor stage. Also, an inline filter is provided to remove any contaminant particles present. This treatment is called primary air treatment. In the third stage, which is the secondary air treatment process, further filtering is carried out. So you can see here. So there is a secondary air treatment and there is a air service unit. It is provided. That is for further treatment, filtering treatment. So in the third stage, which is the secondary air treatment process, further processing or the further filtering is carried out. A lubricator introduces a fine mist of oil into the compressed air. So this will help in lubrication of the moving components of the system, to which the compressed air will be applied. Then filters, we will see the filters. To prevent any damage to the compressor, the contaminants present in the air needs to be filtered out. So this is done by using inlet filters. These can be dry or wet filters. Dry filters are disposable cartridge. In the wet filter, the incoming air is passed through an oil bath and then through the fine wire mesh filter. Dirt particles cling to the oil drops during bubbling and are removed by wire mesh as they pass through it. In the dry filters, the cartridges are replaced during servicing. The wet filters are cleaned during detergent solution. Then the cooler. As the air is compressed, the temperature of the air increases. Therefore, the air needs to be cooled. This is done by using a cooler. So you can see the cooler that is placed in a primary air treatment. You can see the cooler. So it is a type of heat exchanger. There are two types of coolers commonly employed. For example, air cooled and water cooled. In the air cooled type, ambient air is used to cool the high temperature compressed air, whereas in a water cooled type, the water is used as a cooling medium. These are counterflow type coolers where the cooling medium flows in a direction opposite to the compressed air. So during cooling, the water vapor present will condense, which can be drained away later. So main line filter. So these filters are used to remove the water vapors and solid contaminants present in the pneumatic system main lines. So these filters are in details that are given. So air filter or water trap. So filter and the water traps is used to prevent any solid contaminants from entering in the system and condense and remove water vapor that is present in a compressed air. So you can see the air filter and water trap that is shown in a diagram. So air cartridge is made of sintered brass. The thickness of sintered cartridge provides random zigzag passage for the air to flow in, which helps in arresting the solid particles. The air entering the filter swirls around due to the deflector cone. The centrifugal action causes the large contaminants and water vapor to be flung out, which hit the glass bowl and get collected at the bottom. A baffle plate is provided to prevent the turbulent air from splashing the water into the filter cartridge. At the bottom of the filter bowl, there is a drain plug which can be opened manually to drain off the settled water and solid particles. Then dryers. So these are the refrigerated dryers. The diagram it is shown, it acts as a heat exchangers to cool the air. So it consists of two heat exchangers, refrigerant compressor and the separator. The dryer chills the air just above 0 degrees Celsius, which condenses the water vapor. The condensate is collected by the separator. However, such low temperature air may not be needed at the application. Therefore, this chilled air is used to cool the high temperature air coming out of the compressor at heat exchanger 2. The moderate temperature dry air coming out of the heat exchanger 2 is then used for actual application, while the reduced temperature air from the compressor will further be cooled at heat exchanger 1. Thus, the efficiency of the system is increased by employing the second heat exchanger. So, then next is air lubricator. So, you can see to lubricate the system to prevent the corrosion, the lubricator it is used, and these are the all the elements that are shown in a diagram for the lubricator. The compressed air is first filtered and then passed through the lubricator in order to form a mist of oil and air to provide lubrication to the mating components. So figure shows the schematic of a simple lubricator. The principle of working of venturimeter is followed in the operation of lubricator. The compressed air from the dryer enters the lubricator. Its velocity increases due to a pressure differential between upper and lower exchanger, that is oil reservoir. Due to the low pressure in the upper chamber, the oil is pushed into the upper chamber from the oil reservoir through a siphon tube with check valve. The main function of the valve is to control the amount of oil passing through it. The oil drops inside the throttled zone where the velocity of air is much higher and this high velocity air breaks the oil drops with tiny particles. Thus, a mist of air and oil is generated. The pressure differential across chambers is adjusted by a needle valve. So it is difficult to hold an oil mix air in the air receiver as oil may settle down. Thus, air is lubricated during secondary air treatment process. Low viscosity oil forms better mist than high viscosity oil and hence ensures that oil is always present in the air. So this is a lubricator. There is a oil mist, then the oil drops, then there is a glass bowl, then there is a air flow, and at the bottom you can see the oil reservoir. There is a check valve, and through the oil outlet the mist of air and the oil particles that will be taken off through the outlet and it will lubricate the system. Then we will see the filter regulator, air filter regulator or air regulator, a device that used primarily for regulate pressure and filtering the air for stable source of air to process control equipment such as current to pneumatic transducers and control valve positioners. So pressure is one of the most important aspects in a system. If pressure is too low, the system is powerless, and if it is too high, overpressure affects filters, tools, spray heads, instruments, and any vital tool in a liquid system, piping system. So uses of a pressure regulator. It uses as a control element to ensure the downstream pressure does not exceed a set point, as a safety device to protect equipment from harmful overpressure, to regulate to the correct pressure range so that a flow system or piece of equipment can operate safely and efficiently. So simple definition of regulator: a pressure regulator is a normally open valve that takes a high inlet pressure and converts it to a lower preset downstream pressure. So that is a function of pressure regulator. So this is a pressure regulator that is shown. So as the outlet pressure increases, it flows through the aspirator and acts on a lower side of a diaphragm, causing it to move upward until it balances the force of the range spring. So this balance condition maintains the constant output pressure with changes in supply pressure and output load. In a second diagram, if the output pressure rises above the set pressure, the relief valve opens and bleeds the excess pressure to atmosphere. So this is a working of pressure regulator. Then the service units. So during the preparation of compressed air, various processes such as filtration, regulation, and lubrication are carried out by individual components. The individual components are separator or filter, pressure regulator, and lubricator. So preparatory functions can be combined into one unit which is called as service unit. So symbolic representation that is shown in a diagram. So this is called a FRL unit, filter, regulator, and lubricator. So we will see the details of FRL unit in this slide. So filter, regulator, lubricator, that is FRL units. Since the three components, filter, regulator, and lubricator, are essential components of any pneumatic system, and combine all the three components into one unit called FRL unit. So this is the most important element in a pneumatic system, that is FRL unit. So FRL units are installed at the beginning of the air supply line so that air is filtered, it is regulated, and it is lubricated prior to entering in the system. So that is the main function of FRL units. So this is a FRL unit. You can see on the left hand side there is a filter, at the middle there is a regulator, and at the right hand side you can see the lubricator. So it is the three components that are built in one, that is called the FRL unit. So FRL units. An FRL unit is comprised of filter, regulator and lubricator. They are often used as one unit to ensure clean air in a pneumatic system, but can also be used individually. Having a proper FRL unit installed in a pneumatic system provides higher reliability of the components downstream, reduce power waste due to over pressurization, and increase component lifetime. The three components work together to do the following: filter, remove water, dirt, and other harmful debris from an air system. This is often the first step in improving the air quality. Then regulators adjust and control the air pressure of a system to ensure that downline components do not exceed their maximum operating pressures. So this is the second step in FRL system. And third, that is lubricators reduce the internal friction in tools or equipment by releasing a controlled mist of oil into the compressed air. So this is often done last and or right before the components needing lubrication. Now we will see the next component of pneumatic system, that is pneumatic valves. So valve is a device which is used to control output of the circuit. The main purpose of a valve in pneumatics or hydraulic circuit is control the final output. So valves are divided into number of groups according to what they control. So most commonly used valves are direction control valve, that is DCV, non-return valves, then pressure control valves PCV, and flow control valves, that is FCV. So first is direction control valves. So direction control valves controls the direction of the compressed air in a system. So basic symbol of control valve is a square. Two or more squares are used, each square representing the switching position provided by the valve. So in a diagram, 2 position valve is shown and 3 position valve is shown. So it will provide the connection, disconnection between the lines, and it will control the direction of the flow of compressed air. That is the function of direction control valve. Then pressure control valve. The function of pressure valves is to influence the pressure in an overall pneumatic system or in a part of the system. So pressure regulating valves are generally adjustable against spring compression. The symbols are distinguished according to the following type. So pressure regulating valve without relief port, pressure regulating valve with relief port, and pressure sequence valves. Then last element, that is actuators and output devices. So an actuator is an output device from the conversion of supply energy into useful work. The output signal is controlled by the control system and the actuator responds to the control signals via the control element. So other types of output devices are used to indicate the status of control system or actuators. For example, a pneumatically actuated visual display. The pneumatic actuator can be described under two groups, linear and rotary. So first is linear motion. It involves single acting cylinders and double acting cylinders. And second category of pneumatic actuators is the rotary motion. So it involves air motor and semi-rotary actuators. So single acting cylinders. With single acting cylinders, compressed air is supplied on only one side of the piston face. The other side is open to atmosphere. The cylinder can produce work in only one direction. The return movement of the piston is affected by a built-in spring or by application of an external force. The spring force of the built-in spring is designed to return the piston to its start position with a reasonably high speed under no load conditions. Then double acting cylinders. The construction principle of a double acting cylinder is similar to that of single acting cylinder, but no return spring and the two ports are used alternatively as supply and exhaust ports. The double acting cylinder has the advantage that the cylinder is able to carry out work in both the directions of motion. The force transferred by the piston rod is somewhat greater for the forward stroke than for the return stroke, as the effective piston surface is reduced on the piston rod side by the cross sectional area of the piston rod. Then rotary cylinders. So with the design of double acting cylinder, the piston rod has a great tooth profile. The piston rod drives the gear wheel and a rotary movement results from linear movement. Then air motors. So devices which transform pneumatic energy into mechanical rotary movement with the possibility of continuous motion are known as pneumatic motors. So pneumatic motor with unlimited angle of rotation has become one of the most widely used working elements operating on compressed air. So category of pneumatic motors are piston motors, sliding vane motors, gear motors and turbines. Then advantages of pneumatic system. So clean. So pneumatic systems are clean because they use compressed air. If a pneumatic system develops a leak, it will be air that escapes and not oil. This air will not drip or cause a mess, which makes pneumatics suitable for food production lines. Then second point regarding advantages of pneumatic, it is safe. Pneumatic systems are very safe compared to other systems. For example, use electronics for paint spraying because many electronic components produce sparks and this could cause the paint to catch fire. So in this the pneumatic systems are used. Then reliable. So pneumatic systems are very reliable and can be working for long time. Then economical. If we compare pneumatic systems to other systems, we find that they are cheaper to run. This is because the components last for a long time and because we are using compressed air. Then flexible. Once you have brought a basic components, you can set them up to carry out different tasks. So pneumatic systems are easy to install and they do not need to be insulated and protected like electronic systems. Then disadvantages, the preparation. So compressed air requires good preparation. Dirt and condensates should be removed. Then speed. As air is compressible, it is difficult to achieve uniform and constant piston speed. Then force requirement, low forces compared to hydraulics and noisy operation. The exhaust air is loud, that is noise. This problem is solved due to development of sound absorption material and silencers. Then applications of pneumatics, industrial applications. It is used for material handling, clamping, shifting, positioning, branching of material flow, packaging, filtering, transfer of materials, sorting of parts, stamping, embossing of components. And industrial processes involves drilling, turning, milling, sawing, finishing and forming. So there is a comparison of hydraulic system and pneumatic system. So in case of hydraulic system, working fluid, it is a liquid. In case of pneumatic system, it is a gas. Pneumatic hydraulic system that works at very high pressure and pneumatics that is works at low pressure. In hydraulic system, fluid is incompressible and very high working forces could be developed. In a pneumatic system, working fluid is compressible and moderate forces only could be developed. In case of hydraulic system, it is more compact, self-lubricating effect and mechanical movements of several meters can be achieved. In case of pneumatic system, it is more bulky, no self-lubricating effect and movement is limited. In case of hydraulic, return line is required for oil and frequent replenishment and replacement of oil is required. and heavy tube and pipes are required. In case of pneumatic system, the movement is limited, no reserve oil, hence no return line and no need for fluid refreshment, and light tubing and pipe would be sufficient. And in case of hydraulic system, fire hazard due to inflammable nature of oil and mess and dirt due to oil. In case of pneumatic, no fire hazards and clean system due to air. So this is regarding the introduction to pneumatic system. Thank you.